Hello, everybody, and welcome back to HansonMath.com videos. This is a detailed video on how to take the derivative of an inverse function at a particular point. So the first couple things I'll point out is I have the formula for this in the upper left here. So the formula is as follows. If you want to take the derivative prime of an inverse function, so the inverse of f has a derivative at some location x, the formula is 1 over f prime of f inverse of x. And I think to make this make sense, you need to look at it in context where you're looking at the graph of f of x and the graph of f inverse. So on the two examples we're going to look at, I've done just that. I have the original f of x in red dashed, and I have its inverse in solid bold blue. So if we mosey on to example 1 here, you will see the following. You will see that we have the graph of x cubed minus 7. We have that in red dashed. Okay, the graph of x cubed minus 7 is in red dashed. And I've also graphed the inverse of that, which is in blue. So you'll notice a couple of things. Notice that the graph of the red x cubed minus 7, it's kind of tall and skinny, and its inverse is kind of wide and not very tall. All the coordinates are reversed. So whatever coordinates the original function has, for example, if the original, which I will call the OG, if the OG function contains something comma 20, then you automatically know the inverse must contain 20 comma something, because every graph and its inverse have the opposite coordinates or swapped coordinates of each other. So in this problem, it says, find the derivative of the inverse evaluated at the given value of x. So number one, we're trying to figure out what is the derivative or slope of the inverse function at x equals 20. So graphically, let's take a look. So on the graph, when x is 20 on the inverse function, we're right about here. And if you look at the slope of the graph, or the slope of the tangent line to the graph, basically the slope of the tangent line is going to overlap with the graph because it's so flat. So it's a barely rising slope. It's not horizontal, which would be a slope or a derivative of 0. It's just slightly rising. So you can expect the slope, which is the derivative, to be a very small positive. So I'm expecting the outcome of this problem to be a small positive because this slope is so flat and barely rising. The derivative, which is the slope of the tangent line or the slope of the graph at this point when x is 20, is such a mild positive slope. So I expect a small negative, so we'll see. Okay, so how to proceed algebraically, we'll do the following. The first thing that we need to nail down is some coordinates. So it says we're trying to find the derivative of the inverse of f when x equals 20. So that means that when x is 20 on the inverse functions graph, what is the output? And then likewise, on the original OG function, the input is whatever it is, and the output is 20, okay? So we know on f of x, the output must be 20. So we can literally set f of x, the output, equal to 20. So 20 equals x cubed minus 7. And again, the reason we can do this is because if we know we're plugging 20 into the inverse function, we have to get that out, right? So whatever goes into the inverse has to come out on the original. So that means that since we're plugging 20 into the inverse, it comes out of the original. So that means for the original f of x, we set the output equal to 20. So 20 equals x cubed minus 7, and now we solve. So solving for x is not bad. We add 7 to both sides. When you add 7 to both sides, you get 27 equals x cubed. And then finally, you take the cube root, or you ask yourself, what times itself is 27? And the answer, of course, is 3. So x equals 3. So on the original graph, when you plug in 3 for x, you get out 20. And you would see that if you go over to 3 up to 20, we'd be somewhere up here, way up off the graph, okay? Over 3 comma 20 on the red. And then on the inverse, we contain the coordinate 20 comma something. Well, since they're reversed, if the original is 3 comma 20, the inverse is 20 comma 3. And that's exactly where this point is located. It is at 20 comma 3. Okay? Now, we're not interested per se in the y coordinate. We want the slope here, which we said is a mild, very small positive. So now we're going to use this information and proceed. To use the formula, we also need to know the derivative of f, or f prime. So we can find the derivative of f very easily right here using the power rule. So to fill out and answer f prime of x would be the derivative of x cubed, which using the power rule would be 3x squared. And the derivative of 7 here, since it's a constant, is 0. So our derivative is just 3x squared. So now, putting all the pieces together, I'll switch to blue. The formula for the derivative of the inverse at x, and in this case, we're interested when x is 20. So I'm going to kind of fudge this into a 20 when x is 20. The formula is 1 over the derivative, and the derivative here is 3x squared. But instead of putting 3x squared on the bottom, I'm going to put 3 times something squared, okay? And if you look up at the formula up above, now we're right here. We're at f inverse of x, which is f inverse of 20. So if you use a little script we wrote out, when you plug in 20 to the inverse function, it spits out a 3. So when you plug in 20, because it says what happens when x is 20, when you plug in 20, you get out a 3. So 3 goes right here. So instead of the derivative on the bottom being 3x squared, it's 3 times 3 squared. So when you simplify this, you get 1 over 3 squared is 9 times the 3 in front is 27. So your answer is a derivative or a slope of 1/27th. Now, 1/27th is a very small number, which totally agrees with the graph. You have a very small positive slope because it's really quite flat right here. So all is good in the world. That is correct. The answer is 1/27th. And as a bonus, now I'm asking for the equation of the tangent line to the inverse function when x is 20. So that's in, let's use point slope form. In point slope form, it's y minus the y coordinate of the inverse function, which is 3, equals the slope, which is the derivative we just got, 1/27th times x minus the x coordinate from the inverse function, which was 20. Okay, so that is the work and the thinking and the solution to number 1. All right, next we will skip down to number 3 for variety. Okay, in number 3, first we're going to take a look at the graph. So we're looking for the derivative of the inverse of f when x is 4. So again, the square root function, f of x, the OG, that's in red, and the inverse of that is plotted in blue. So when x equals 4 on the blue function, we are over 4 down here. So let me switch colors. We're here. So if you look at the slope of the tangent line or the slope of the function right here, it's very negative. It's very downhill and steep. So since it's downhill and steep, I'm imagining the derivative or the slope is going to be a sizable negative. So it's going to be a fairly large negative outcome because it's so steep and so downhill. Okay, that type of slope, steep and downhill, gives you a large negative derivative. So let's see if that is the case. Okay, so since we're trying to find what the slope is when x equals 4 on the inverse function, that means that if 4 is the input on the inverse function, it's the output on the original OG function. So since 4 is the output, aka f of x, we replace f of x with 4. So 4 equals the square root of 8 minus 2x. Now we have to solve for x. Well, to undo the square root, we can simply square both sides. So if we square both sides, we'd have 4 squared. Let's see here. I'm going to put an arrow because we're going. 4 squared is 16. When you square a square root, the square root goes away. So you just have 8 minus 2x. If you subtract 8 to both sides, you'll get 8 equals negative 2x. And then finally, you should get x equals negative 4. Okay? So on the original function, when x equals negative 4, on the original function, we can see this on the graph. On the original function, when x is negative 4, we're up here at positive 4. And then on the inverse function, which is blue, it has to be reversed. So instead of negative 4 in, 4 out, it has to be 4 in and negative 4 out. And you're going to see on the dark blue thick function, we do have the coordinate 4 comma negative 4, which is right here. That's at 4 comma negative 4. Okay, so now that we have our coordinates figured out, we can proceed by finding the derivative of f. So the derivative of f is f prime. So one housekeeping thing is I'm going to change the square root to the power of 1/2 because that plays well with derivative rules and chain rule and specific. So to take the derivative of 8 minus 2x quantity to the half, we'll use the chain rule. So the 1/2 comes in front. You keep your inside function, leave it alone, 8 minus 2x. You subtract 1 from your exponent, 1/2 minus 1 is negative 1/2. Now chain times the chain, the derivative of the inside here is negative 2. Okay, let's simplify a little bit. Here we have 1/2, and then at the back end we have times negative 2. 1/2 times negative 2 is negative 1. Half of negative 2 is negative 1. And then everything here that's subjected to the negative 1/2 power, the negative power is the reciprocal, which sends it to the bottom, and the 1/2 power is the square root. So we have the square root of x minus, or 8 minus 2x in the bottom. So that is our derivative, or f prime of x. So finally, to put everything together, we have the following. F inverse has a derivative when x is equal to 4, and we'll use the formula. The formula is always 1 over f prime. F prime in this case is right here. So that's negative 1 over the square root of 8 minus 2 times something. And this x right here, which I'm leaving open, that's when x is 4, what is f inverse? And in this case, it's negative 4. Okay? So this negative 4 right here is coming from here. That's f inverse of 4 is negative 4. So now we simplify. So we have 1 on top. On the bottom, we have negative 1 over, let's see, negative 2 times negative 4. This becomes 8, positive 8. 8 plus positive 8 is square root of 16. So then we have 1 over, negative 1 over, square root of 16 is 4. And then 1 over negative 1/4 is the reciprocal of negative 1/4, which is negative 4 over 1, or just negative 4. So the derivative to this inverse function is negative 4, which is the slope. And this totally could be and is a slope of negative 4 right here, because it is a large negative, down 4 units over 1, down 4 over 1. That is the slope right there. So it's perfect. And to put this one to bed, we can write the equation of the tangent line. It would be y minus the coordinate, the y minus the y coordinate of the inverse function, which is negative 4. So minus negative 4 is plus 4, equals the slope we just got, the derivative is negative 4, times x minus the x coordinate of the inverse function, which is 4. So that is a short lesson on how to find the derivative of the inverse function at a particular point. Okay, I like to do it in 3 steps. Step 1, identify the coordinates of f of x and f inverse of x. Number 2, find f prime. And then number 3, use the formula to solve. I hope this helps. Thank you for watching. If you enjoyed this video and thought it was helpful, please like and subscribe, and we'll see you on the next one. Take care, and thank you for supporting HansonMath.com.